Hi everyone, I'm Alex Bleakley, the product manager for Amazon FSx for OpenZFS, and I'm here with principal software engineer Mark Roper, and we are very excited to introduce Amazon FSx Intelligent Tiering, which is a new storage class available today for Amazon FSx for OpenZFS. FSx Intelligent Tiering provides elastic, intelligently tiered storage, and it provides a low cost that makes it cost-effective to migrate large, network-attached storage datasets from cost-optimized HDD deployments on premises to a file system with all the same NAS capabilities in the cloud. The storage class being fully elastic means your file system grows and shrinks according to the amount of data you store, and you only pay for that amount of data. And that means your file systems never fill up, you never pay for storage you don't use, and you don't have to spend operational effort monitoring storage utilization and managing storage space. It's intelligently tiered, which means that it automatically moves less frequently accessed data to lower cost tiers. And that means that you can retain data more cost effectively while still having access to that data when you need it, without having to manually move data back and forth between locations. And crucially, the new storage class reduces storage costs for NAS datasets by up to 85% relative to FSx's existing SSD storage class, and up to 20% compared to traditional HDD-based NAS deployments on premises, which means you can now bring large NAS datasets from HDD on premises to the cloud cost-effectively. Today, I'll start with a brief recap of what Amazon FSx is, and specifically FSx for OpenZFS, where we're launching the new storage class. Then I'll talk about the customer challenges that motivated us to build FSx Intelligent Tiering, and the key benefits of using the new storage class. Finally, I'll hand over to Mark, who will dive into the details of how we made this possible, how the new storage class works, and when you should use FSx Intelligent Tiering. First, let me start with a recap of what Amazon FSx is for anyone who's not familiar. FSx provides fully managed network-attached storage in the cloud with like-for-like functionality relative to NAS file systems on premises. So you can migrate your datasets and applications to AWS without having to re-architect those applications or redesign your workflows. FSx takes care of provisioning, scaling, and maintaining file system infrastructure and automatically ensures high availability and durability, so you don't have to do the operational heavy lifting to set up and maintain file systems in the cloud. FSx builds on the latest AWS compute, disk, and networking technology to deliver cutting-edge performance and continual improvement as the next generations of those underlying technologies become available. And FSx provides native integrations with a variety of AWS services like EKS and Parallel Cluster, so you can easily take advantage of the elasticity of the cloud. We've built these like-for-like solutions for 4 popular file systems: FSx for Windows File Server as a destination for Windows-based file storage on premises, FSx for NetApp ONTAP for customers with NetApp ONTAP file systems on premises, FSx for OpenZFS for NAS deployments built on the open source OpenZFS file system, and FSx for Lustre for customers using the scale-out Lustre file system. Today, we'll be focusing on FSx for OpenZFS, where we're introducing the new storage class, Intelligent Tiering. Now, interestingly, while we built FSx for OpenZFS for migrations from OpenZFS-based file systems on premises, what we've actually seen is that customers have chosen the service as a destination, not just for datasets that were already stored on OpenZFS, but also for datasets that were previously stored on a variety of other open source NAS file systems and other commercial NAS offerings. And the reasons these customers tell us they picked FSx for OpenZFS fall into these 3 categories. First, OpenZFS has an extensive set of NAS capabilities. So customers who were using other solutions on premises typically find that everything they were doing before, they can also do with FSx for OpenZFS. And those capabilities include user and group quotas for managing storage usage, compression to reduce costs, and data management features like point-in-time snapshots, zero-copy clones, and on-demand data replication across file systems. Second, some of those customers need high performance, which they get with FSx for OpenZFS because it has SSD-based file systems and because it is built on the open source OpenZFS file system, which itself is purpose-built for high performance. And that means you get sub-millisecond latencies, up to 21 gigabytes per second of throughput, and millions of I/O operations per second. Third, because OpenZFS is open source, with FSx for OpenZFS, you get all the benefits of a fully managed and supported offering without the licensing costs that come with most commercial file systems, which translates to over 30% better price performance relative to those commercially licensed offerings. So we've seen customers have success with FSx for OpenZFS across a variety of use cases and verticals, especially because of those NAS capabilities and high-performance characteristics I just talked about. For example, customers use FSx for OpenZFS as a storage layer for their databases and use the data management features like consistent point-in-time snapshots and zero-copy clones to let analysts and developers continue working with a point-in-time copy of the database without creating a separate copy of the data. In other cases, they use the on-demand data replication feature to create a separate point-in-time copy of the database on a different file system to intentionally segregate their production and development workloads. As another example, customers use FSx for OpenZFS for performance-intensive workloads like semiconductor electronic design automation because of the sub-millisecond latencies, high throughput, and high levels of I/O operations that allow them to complete simulations faster. So FSx for OpenZFS with SSD storage has been great for customers who need a high-performance file system with NAS capabilities. But there are also a few challenges that we hear consistently from customers with large NAS datasets. The first is that customers find that growth in their datasets can be unpredictable, and that datasets both grow and shrink. So it takes a lot of operational effort to make sure they don't run out of storage space, while also not paying for more storage than they need. And it's especially challenging to scale down after a temporary spike in data storage needs. The second challenge is that many of these NAS datasets are growing at an ever faster rate, especially as trends over the last decade in analytics, machine learning, and most recently AI mean that customers want to retain their data for longer for its future value. And so, more than ever, customers are looking for ways to cost optimize for these growing datasets, especially data that's less frequently accessed. Finally, customers find that high-performance, all SSD storage is cost-prohibitive for many of the large, sometimes petabyte-scale datasets that customers store on HDD or hybrid SSD-HDD deployments on premises. And that meant they couldn't bring those datasets to SSD-based file systems with FSx for OpenZFS. So with these three challenges in mind, we took a step back to consider what we were already providing for our customers and what additional capabilities they needed us to provide to solve these challenges for their large, growing datasets. What we were already providing were those NAS capabilities that match the functionality of their file systems on premises, combined with some of the core benefits that bring customers to AWS, a fully managed service, excellent price performance, and integrations with a rich AWS ecosystem that allows those customers to benefit from the agility of the cloud. At the same time, those additional challenges that I just mentioned that customers needed us to solve corresponded to capabilities of other AWS services that were built for the cloud from the ground up, like S3 for object storage, EFS for file storage, DynamoDB for key value stores. These services also provide those same core AWS benefits we provide on FSx for OpenZFS, but they also have some other cloud-native capabilities in common. First, they're all fully elastic, which means your storage automatically grows and shrinks as you add and delete data, and you only pay for what you use. And this is great for those unpredictable data sets because it means customers don't have to monitor storage utilization to avoid running out of space, and they don't have to pay for unused storage either. Second, they all have the option to automatically tier colder data to lower cost storage tiers based on how frequently the data is accessed. So you automatically get cost savings for that less frequently accessed data. And that's really important for those growing data sets we discussed because it means customers can cost optimize the storage of inactive data without having to manually identify and move such data back and forth between storage locations. And finally, they all offer lower cost storage options, including those lower cost tiers for colder data, which makes them suitable for bringing HDD-based datasets to the cloud. So wouldn't it be great if customers with network-attached storage could get those same elasticity, automatic tiering, and low-cost storage options in a single solution that also provides the NAS capabilities that their applications and users rely on. Well, that's exactly what we set out to achieve, and as a result, I'm excited to announce the launch of Amazon FSx Intelligent Tiering, a new storage class available today on FSx for OpenZFS. With this new storage class, FSx for OpenZFS combines the functionality of a network-attached storage with storage that's fully elastic, intelligently tiered, and low cost. Just like with those cloud-native storage solutions I mentioned, such as Amazon S3, the new storage class automatically grows and shrinks to fit your data as you add and delete files, meaning that you no longer need to manage storage capacity, pay for storage you're not using, or worry about accommodating unpredictable data sets. And just like with S3's own intelligent tiering storage class, this new FSx storage class automatically optimizes costs by moving data across storage tiers. And that means you can keep less active data around for longer without the operational effort of identifying inactive data and moving it between storage solutions. Finally, FSx Intelligent Tiering reduces storage costs for NAS datasets by up to 85% relative to the existing SSD storage class and up to 20% compared to traditional HDD-based NAS deployments on premises. So you can now bring HDD-based datasets from on-premises to FSx for OpenZFS cost-effectively. Let's talk about how intelligent tiering works and how it reduces your costs. The new storage class comes with 3 tiers: frequent access, infrequent access, and archive instant access, with the lower 2 tiers cost-optimized for colder data. Just like with S3 intelligent tiering, data moves automatically to the infrequent access or archive instant access tier when it hasn't been accessed for 30 or 90 days, respectively. And all data, regardless of which tier it's in, is always instantly retrievable, with tens of milliseconds first byte latency. The storage in each of these tiers is fully elastic, meaning that you don't have to choose a file system size or monitor storage utilization, and you pay storage costs for the amount of data you actually store. And we are really excited to talk about pricing because for the first time, we're bringing the elastic pricing model and the ultra-low prices of S3 to FSx for OpenZFS. For data stored, you pay per gigabyte per month, depending on which tier the data is in. The prices on screen are for the US East 1 region, and if you've used S3 intelligent tiering, these numbers will probably look familiar because they're exactly the same as you pay on S3. And as with S3 intelligent tiering, you also pay a small fee for the monitoring and automation that tiers your data to get those automatic cost savings. And in this case, that's also charged per gigabyte month. When it comes to accessing your data, historically on FSx, you would provision a specific amount of IOPS and pay per month for that amount of IOPS. But with intelligent tiering, there's another place that we're introducing elasticity, replacing that provisioned IOPS model with the notion of requests so that you only pay when you actually access your data. Again, you might notice the analogy to S3 here, and again, the prices are the same as for S3 intelligent tiering. These are the prices you pay each time the file system reads or writes a block of data from or to intelligent tiering. And Mark is going to go into more detail later about what constitutes a block of data and how FSx works to optimize these requests and minimize your costs. And this is what that pricing works out to for a few example datasets. First, we look at a very hot dataset where most of the data is being accessed frequently. This could be a streaming workload, for example, where most of the time you're not keeping the data around for more than 30 days. So at any given time, most of your data is in the frequent access tier. And because this dataset is very active, it also has a relatively high number of read and write requests. This example, including those requests, works out to 3.5 cents per gigabyte month of data stored for storage and the requests. And because one of the NAS capabilities of FSx for OpenZFS is transparent data compression, you also get savings from compression. And that equates to 2.5 cents per gigabyte month for the storage and requests at a compression ratio of 50%. Next, we have a workload which is representative of what we typically see for customer datasets. For example, this might be an analytics workload with a mix of daily reports and ad hoc analysis. And you'll notice here that even though this is a typical dataset, we actually have a majority of data in the coldest tier, archive instant access. And this is what's really great about intelligent tiering. The whole data set is available in the file system, and the users might need access to any given file at any moment. So it would be really challenging to try to manually break up this data set and archive some portions of it to save costs. But when you look at the actual access patterns of this typical data set, at any given point in time, a lot of that data actually hasn't been accessed recently. And with intelligent tiering, you automatically get very significant cost savings on that data, pushing the effective cost after compression down to 0.7 cents per gigabyte month. Finally, we have an archival data set where 80% of the data hasn't been accessed in the last 90 days. And here, the effective cost after compression is less than ½ cent per gigabyte month. But still, even though this is an archive data set and most of the data is in the coldest tier, all of that data is still accessible on demand in milliseconds. Let's talk a bit more about the product experience. First, because this is an FSX for OpenZFS file system, you still get all of the same functionality you get with the existing SSD-based file systems. That means your file system clients mount the file system over NFS in exactly the same way, and you get all those NAS capabilities I talked about earlier, like point-in-time snapshots, zero-copy clones, on-demand data replication, and user and group quotas. The file systems come with a pair of file servers in 2 different availability zones, and they synchronously replicate state. So your file system is highly available and resilient to failures with an availability SLA of 99.99%. So what about performance? For data in any of those 3 intelligent tiering tiers, the data is instantly retrievable with first byte latencies in the tens of milliseconds, independent of which tier the data is in. But we also have some optimizations to help you get the best of both worlds in terms of intelligent tiering's price and SSD performance. First, all file systems using intelligent tiering come with a built-in SSD write log to speed up all writes to a first byte latency of about 1 millisecond. And that write log is replicated both within and across availability zones, so those writes are fully durable as soon as they're acknowledged. Additionally, you can choose to provision an optional SSD read cache to provide low latency reads of recently accessed data for latency sensitive or IOPS intensive workloads. And what's great about this is if you have a data set where a subset of your data is in active use, and then you also have a long tail of less active data that you might need access to, but which is typically very cold, then you can have that active data in the cache, so all of your writes and most of your reads are served with SSD latencies. But at the same time, the majority of your data is stored in the colder tiers of intelligent tiering. So you have a lower overall cost per gigabyte. So you're getting both high performance and the low cost of intelligent tiering. Let's look at an example of that combination of high performance and low cost. Let's say you're providing user home directories for over 200 users, and those users are currently storing about 126 terabytes of data after compression. Immediately, we can see the benefits of elasticity here, because with the provisioned SSD storage class, if you're following the best practice of keeping your file system at about 70% utilization, you'll need a file system that's 180 terabytes in size. And of course, you're going to need to monitor that storage utilization and scale the file system as the data set grows. On FSX intelligent tiering, on the other hand, because it's elastic, the file system automatically scales up and down, and you only pay storage costs for the data you store. Now, on the FSX intelligent tiering side, we also want to provide those users with low latencies, the millisecond level latencies when they read their data. So we also provision an optional SSD read cache of 25 terabytes, and that more than covers the amount of data those users are accessing frequently at any given time. In terms of performance, first, both of these file systems support throughput of up to 10 gigabytes per second, depending on the file server performance level you provision. The SSD file system provides P50 write latencies of around 1 millisecond. And because of that SSD write log that comes included with all file systems using FSX intelligent tiering, we have those same P50 write latencies for intelligent tiering. The SSD file system provides P50 read latencies of around 1 millisecond. As for intelligent tiering, because we had that SSD read cache, and because user home directories tend to be very cache friendly, we again get those same 1 millisecond P50 read latencies on FSx intelligent tiering. And the only difference here is those longer tail latencies in the tens of milliseconds for the infrequent reads of data that hasn't been accessed recently. So overall, we have very similar performance profiles, and yet, in this example, even after we include the SSD cache and the request costs, we save 81% relative to provisioning all SSD storage for this use case. And of course, in this example, that means a huge cost reduction for this customer. But that difference also means that for even the most cost-optimized HDD-based data sets on premises, where it was previously cost prohibitive to bring those data sets to SSD storage, the migration to FSx for OpenZFS is now possible. Now, I'm sure some of you are curious about the technical details of how the new storage class works, so I'm going to hand off to our principal engineer, Mark Roper, to talk you through how we built this storage class, how it works, and how you should choose between intelligent tiering and all SSD.
Thanks, Alex. OK, so Alex just introduced you to FSx for OpenZFS with the new intelligent tiering storage class. He talked about how it brings you performance and capabilities of NAS, along with the benefits of fully elastic, intelligently tiered storage. He talked about the really compelling price point and how that enables you to bring even your largest file data sets to FSx and to AWS. For the next few minutes, I want to take you through how we deliver these capabilities and get into more detail about the performance and cost optimization benefits for you. So FSx intelligent tiering is implemented at the block layer. And this means that the file system consumes the storage class exactly like it would HDD, SSD, or SAN. And the benefit of this is that it requires no changes to the file system itself in order for the file system to consume the storage class. And it's because there are no changes to the file system that we're able to deliver all of these powerful NAS capabilities that have historically already been available on FSx for OpenZFS. So as Alex had mentioned, a highly available active-passive failover deployment spanning 2 AWS availability zones, a high-performance SSD read and write journal, data compression, user and group quotas, zero-copy read-write clones of your data sets, zero-copy snapshots of your data sets that you can send between file systems within an availability zone or across AWS regions, and more features. And on the other side of the block interface, this is where FSx intelligent tiering is implemented. Intelligent tiering is built on the same storage technology underlying Amazon S3. And this explains why the pricing model Alex walked through is exactly the same as S3, and why you'll probably be familiar with the model already. What it means is that FSx intelligently tiered data is stored across 3 availability zones, at least 3 availability zones. It means that the intelligent tiering moving your data between the storage classes within intelligent tiering is working the same way as it works on Amazon S3 in order to optimize your costs. If you write file data to the file system, it's going to start off in the frequent access tier. If you don't touch it for 30 days, it moves down and your costs go down. If no file workload touches it for another 30 days, it moves down again. And again, the file system has to know nothing about this. This is just a benefit of the storage class itself. However, that data remaining available, no matter which class it's within, is really important. Again, the file system, it doesn't need to know anything about what's happening underneath the block layer. If you access a file that hasn't been accessed in a year, it will be retrieved, it'll be brought into frequent access, and you'll be paying the price that's optimized for more hot access. So as Alex mentioned, intelligent tiering is fully elastic. You're only paying for what you use. You never run out of space. And these things are really important. There's no operational overhead. You're never calculating required storage. But if you decide you want to limit storage for users or groups, you can still use the capabilities of the file system, user and group quotas, to control cost or to manage user behavior if you want. But you don't need to do that. So let's talk about what some of the optimizations are and how we're delivering the performance. So the OpenZFS file system is working together with intelligent tiering to deliver you high-performance SSD-like capabilities. We're talking about hundreds of thousands of write IOPS. We're talking about the low cost of intelligent tiering, sub-millisecond latencies. How is that really happening? So the OpenZFS file system is acknowledging an I/O request as soon as it's written to low-cost low latency SSD storage. Let's walk through one example. The file system client performs a write. The file server immediately puts that in the SSD write log, and it replies, success, you've been durably stored to the client. That takes about 1 millisecond because of the SSD latencies. It's only later that write I/O is aggregated together with other I/Os that are happening on the file server and written to FSX intelligent tiering. And this operation may take tens of milliseconds, but it's completely transparent to the file system client because its I/O was acknowledged as soon as it hit the journal. And the write aggregation, it's not just about performance, it's also about cost. So what happens when multiple writes are coming in to multiple different files on your file system at the same time? Well, those file writes are acknowledged back to the clients as soon as they hit the journal, but they're aggregated together in memory before they're written to FSX intelligent tiering. This increases the throughput of the file server to the storage class, but it also creates really material savings for you on your workload. So recall that Alex discussed request pricing earlier. You're metered for each read and write I/O that occurs to the intelligent tiering storage class. But you're not charged for the file system I/Os, which might be small random writes or updates. You're charged for the aggregated I/O, and those aggregated I/Os can be from multiple different writes to the same or different files in the file system. FSX intelligent tiering will aggregate those writes up to 4 megabytes in size. Okay, what about read I/O? So like with write I/O, on the read side, the OpenZFS file system is working together with the storage class to get you the benefits of the pricing and the costs, but also the high performance. So here you've got 3 columns from left to right. Every read I/O is going to be served from either the in-memory cache on the file server, the SSD cache, or directly from intelligent tiering. The first thing to notice here is throughput. So even though we have intelligent tiering storage, it's tens of milliseconds, you can still drive the throughput that you can to your SSD cache, which is exciting. On IOPS and latency, you can see that the SSD cache gives you an order of magnitude higher IOPS and the sub-millisecond latencies. So what you really want for your IOPS heavy and latency sensitive workloads is to have your reads served from SSD cache or from memory, ideally not from the primary storage on FSX intelligent tiering. And this is happening in a couple of ways. First, ZFS implements a really nice caching algorithm that's optimizing retaining in memory and on SSD cache your most frequently read and your most recently read data. So any of your read workloads that are accessing this most recently or most frequently read data will be hitting either RAM or the SSD cache and not intelligent tiering. So that's great. But there's an interesting additional optimization in place in OpenZFS that makes this even more exciting. That's called prefetch. So prefetch is an optimization that's in place to serve file read requests from cache, even for data that's not already in the cache. And let me explain how that works. So again, the ideal system would be trying to serve every read it can for performance reasons out of memory or out of SSD cache. But it would be retaining colder data in FSX intelligent tiering for its low cost benefits. So how does this work? What is prefetch? The ZFS file system detects when a workload is accessing file system data sequentially within a set of files. So it identifies that a read request is reading the first megabyte of file, and then the second megabyte, and the third. And what it does is it anticipates future requests that are sequential, and it goes and it makes those requests to the storage layer before the client even makes the request to the file system. This way, when the client does make the call to read data that it's never read before, that data can be served directly out of the cache with the high IOPS and low latency that we discussed. So it's effectively converting sequential, uncached read workloads into cached reads, even for the very first access of data, which is really exciting. The more sequential the access pattern is hitting the file system, the more aggressive ZFS will be about reading, prefetching more data from the colder storage and bringing it into the cache. So if you're doing random I/O, you're not going to have to pay a huge overhead for the prefetch behavior. But if you're doing sequential I/O, you'll get a really nice benefit there. So prefetch, along with the ZFS cache optimizations for most frequently and most recently read data, and the write aggregation that we talked about with the write journal, These are really the key enablers of high-performance workloads running on OpenZFS with the intelligent tiering storage class. We think that's pretty exciting. Let's take an example like software build. So one use case for shared NAS storage is to compile software artifacts, store them. And this can involve, at the compile phase, performing many small, random read and write IOs, often in parallel. Latency can impact the runtime and the cost for these workloads. And so a lot of customers will choose SSD storage for these workloads. But after compilation, it's often the case that these artifacts will be stored for a long time on the file storage. And this is where the intelligent tiering storage class becomes interesting again. So with FSX for OpenZFS and the intelligent tiering storage class, we see equivalent compile times building the Linux kernel because the write journal and the read cache on the ZFS file system are making it behave effectively the same way as an SSD-only file system. But as you go and store your artifacts for a longer period of time on the file system when they're cold, the effective cost to store those artifacts is much lower on intelligent tiering than on an all SSD file system. So in this example, with 18 terabytes of colder storage, we'd see a 71% lower cost, total cost for the workload. And we think this is the kind of workload that customers are going to be really excited to use with OpenZFS and with FSX intelligent tiering. Okay, so you might be wondering, when should I use this thing and when shouldn't I? So the FSX intelligent tiering storage class is the right choice for many workloads, even performance-intensive, performance-sensitive workloads. You never run out of space. You never worry about provisioning storage capacity. You get SSD performance on your writes. On many of your read workloads, you're getting SSD performance. And you also pay an incredibly low price for storage. This really unlocks your ability to bring your largest data sets, your largest file data sets to FSX and to OpenZFS. Now, FSX also does offer, and has for years, provisioned SSD deployments. And these are great for workloads where all reads require the lowest possible latencies and where access patterns are truly random so that the benefits of the read cache are more muted. If you're going to access the entire data set stored in the file system at random, provisioning a 10% read cache isn't going to help you too much, right? So there are some examples like this, like some electronic design automation workloads have small I/O and are truly random access across the entire file data set. They'll continue to use SSD only. Some database workloads really require the lowest latencies for all reads, and they can continue to use SSD. So we on FSX and AWS will continue to invest in having the highest performance provisioned SSD experience that we can. But that said, it's the right choice for many workloads, including performance-oriented workloads, to take a look at FSX intelligent tiering. Okay, one more topic. What about backups? So all FSX file system storage classes today support file system backups, and FSX intelligent tiering does as well. For every FSX storage class, intelligent tiering included, we offer independent backups. And this means that the backup data is stored independently of your file system so that you can use that data for disaster recovery, for ransomware protection, to do experimentation workflows, and the data is fully segregated from the active file system. Backups are also point-in-time consistent, and this means that a new file system can be created from a backup, and it will contain all of the data that was in the backup from the file system at the time the backup was created. Backups are compression enabled, so you can save on your storage costs, not just on the active file server, but also on your backup. Backups are incremental, so if you're bringing petabyte scale workloads to FSX for OpenZFS, you can take a backup every day, and you'll only be paying to store the incrementally changed data in the file system from the previous backup. Finally, backups are stored on S3, fully independently of the file system. So intelligent tiering, we built it for large data sets, and there are important things that we've done to support effective backups for you for the large data sets. The first is this incrementality that I mentioned, and this really matters for your costs. So you can be taking a petabyte scale file system, you can be taking backups incrementally without incurring huge cost, or waiting a long time, importantly, for your backup to be created. If you're taking a backup every day and there's only a small amount of churn on the file system each day, you're only needing to copy and wait to copy a relatively small amount of data despite the large total size of your data set. When you take a backup, Active file system I/O is not impacted by the ongoing backup, and backups are completed quickly because only incrementally changed data needs to move. The second benefit really is around recovery time. So imagine a situation where you need to restore a new file system from a backup of the file system. Say, for example, an administrative user wrongly deleted data from the active file system and you needed to get back online. So these can be really urgent things. Recovery time matters a lot. With backups of FSx intelligent tiering file systems, restores are very fast. When you're restoring a backup to a new file system, that file system will be ready to use within 5 minutes of making the request to restore. Data is loaded into the new file system from S3. It's done in the background, but it's also done on demand, which is why you can immediately start using the file system when it's being restored from the backup. What this means is you can support even very demanding recovery time objectives with this new backup type on the new storage class for arbitrarily large file systems. So to wrap up, FSx for OpenZFS with the new FSx intelligent tiering storage class combines powerful capabilities and performance to meet the needs of the most demanding NAS workloads, along with the fully elastic, intelligently tiered, low-cost storage. And we're really excited to see what customers will build on the new FSx intelligent tiering storage class. So with that, thank you, and Alex and I are happy to take any questions that you have.